Alright, I tried and failed. My camera failed, and then I pressed the wrong this and that. Anyways, I already did a lot of it. You just didn't see the video. So question number 1, do the power rule, subtract 1 to the exponent, and the derivative of what's inside the parentheses is your hook. So there it is, and 3 times 3 is 9. Here, 4 times 3 is 12. Subtract 1, the derivative is 7. Here, write it calculus friendly to the half. Subtract 1 to the exponent, the derivative. Write it calculus friendly, negative 2 in front. Subtract 1 to the exponent, the derivative is negative 1. Here we are. This is where I'm at. Write this calculus friendly as an exponent rather than a radical. Cube root means the denominator is 3. Then the derivative would be 2/3 x squared plus 1. Now 2 subtract 3 is negative 1. Use the same denominator. And the derivative of x squared plus 1 is 2x. That's called the hook or hook on. G. Here we go. So number 6 is x times 2x plus 3 to the 3. So in this situation, it's going to be the product rule. We have a first and we have a second. So the derivative here is going to be the first times the derivative of the second. So I'm going to take the derivative, and that includes a hook, plus the second times the derivative of the first. I don't need it, but there it is if you want to put it down. And that you don't need to simplify it. Number 7. Right away for number 7, I'm going to write it calculus friendly. So that's going to be x plus 1 to the negative a half. So square root is a half, and the fraction makes it negative, so put it all together. Take the derivative of that is negative a half, x plus 1, subtract 1 to the exponent. And then the hook, the derivative of x is 1. I don't need it, so I'm not going to put it down. Done. Number 8, 3x take away 2x plus 1. The rule here is actually the quotient rule. So the quotient rule is the bottom times the derivative of the top, subtract the top, times the derivative of the bottom, I don't need 1, and then the bottom squared. Number 9, again press pause at any time if you need to. Trigonometry, wonderful. The derivative here, the derivative of secant is secant tangent, and then it has a hook. The derivative of 4x is 4. So know the rule. The inside stayed the same, and then the derivative of 4x is 4 is what gets hooked on at the end. 10. Y equals 4 tangent 2x. So first the rule for tangent is secant squared. So 4 secant squared 2x, and then the derivative of 2x is 2. That's the hook on, and definitely you could go 2 times 4 is 8 and have that in front. Number 11, theta, one of my favorites. Now I think it's helpful to write it this way, so I'm going to write it sine 3 theta squared, like that. So that you understand when you do this, it's the exponent 2 times a half. Well, that's 1. I don't need to put it there. And then sine 3 theta. When you subtract 1 to the exponent, it's 1. I don't need that either. And then the last part, the derivative of 3 theta is just 3. So think of theta as x or t, just a variable, and you have it. Number 12. Oh, there's a part I missed. Let's try this again. So 2 times a half is 1. Write down sine 3 theta, and it's 1. That's beautiful. But now, what's the derivative of what's inside? It's not just 3 theta, it's sine 3 theta. So the derivative of sine is cosine, and then the derivative of 3 theta is 3. So it had an extra hook there. So I had to be careful. This is the part I forgot. So inside the parentheses, the derivative of sine is cosine. Write it down, and then the next hook, the derivative of 3 theta is 3. Number 12. I'm going to write number 12 down here. Number 12. So calculus friendly, step 1 for calculus friendly is I'm going to simplify the fraction. So I'm going to write it as 4x cubed divided by 2x and 2x divided by 2x. Not doing any calculus yet. So this becomes 2x squared. This becomes 1. Now the second part to make it calculus friendly is 2x squared minus 1 to the half. And now you can take the derivative. So 1/2 times 1 in front. Subtract 1 to the exponent. The hook would be 4x, and it's done. And you could go 1/2 times 4. That's 2x could be in front. Number 13. So another way you could see this is 2x. Just to know that if you had to, that means the same thing. Number 13. So again, I'm going to write it calculus friendly. So that is 2x squared plus 2 to the half. I'm finding the tangent line. So the x coordinate and the y coordinate and the slope. This is calculus, so I need the derivative for this. That's 1/2 2x squared plus 2 to the negative 1/2, and then the hook. And then to find the slope, I'm going to plug in -1 into the derivative. Now I'm going to simplify it. 4 times 1/2 is 2x. And then we have -1 and so on. So we have -2. This is 1 times 2 plus 2. This is the square root of 4 and then the reciprocal. So that's 1/2. So altogether that slope is -1. So the equation would be -1 x plus 1 plus 2. And there it is. Fun, right? Number 14. In number 14, I have f at x equals x plus 4 over x. I'm going to simplify that right away. That's x divided by x and 4 over x. So that's 1 plus 4x to the -1. That's going to be easier to do the derivative. It says the x coordinate is 2 and the y coordinate is 3. To find the slope, I need to take the derivative and plug in the x coordinate. The derivative here is 0 and -4x to the -2. That's it. Plug 2 in. 2 to the -2, that's 1/4. And then the 4's divide out, and the slope is -1. And then put it all together, so the slope is -1, and then it's x minus 2 plus 3. Number 15. In number 15, they give you the x coordinate and the y coordinate. Those are fancy. And I need to find the slope, which is the derivative at the x coordinate. So I need to know the function. I'm going to write it calculus friendly. So it's like 9x to the -3/2. So the derivative would be -3 over 2, 9x, -5 over 2, and then the hook is 9. I am going to simplify that just a little bit. So this is -27 over 2. If I plug in a quarter, I get 9 over 4. Stick with me here. So I'm going to plug in a quarter, I get 9 over 4. So this is -27 over 2. The square root here. So first of all, the negative exponent will flip this. So it's going to be, the square root is going to be flipped, so it's 2 over 3. I still have the exponent 5 I need to deal with. So this whole thing, what is it going to simplify to? So 2 to the 5 over this or that. The whole thing simplifies to -16 over 9. I don't want you to get a headache over that. And the truth is, on a calculus exam, you could just write that as a slope and not have to simplify it anyways. And then the slope would be negative 16 over 9, x minus a quarter plus 8 over 27. So again, on a calculus exam, in fact, at this step right here, you could just put that in for the slope. Don't simplify and move on. Number 16. Oh, this looks like fun. So the function, I'm going to write it calculus friendly, x to the negative 2 and cosine x to the 1/2. The x coordinate is 2 pi and the y coordinate is 1 over 4 pi squared plus 1. That's just going to be added on at the end. This is what I need to focus in on, and the slope is the derivative at 2 pi. So the derivative here is negative 2x to the negative 3. The derivative here is 1/2 cosine to the negative 1/2. And then the derivative of cosine is negative sine. Now, when I plug in pi, or 2 pi, 2 pi is right here. And the x coordinate is 0. And I'm only saying that because once you plug in 2 pi here, this is equal to 0. This is 0. So 0 times whatever. This whole thing here is 0. And what I'm left with is negative 2 over 2 pi to the 3. That's what the slope is. You could also simplify it. And the equation line then would be negative 1 over 4 pi cubed, that's the slope, x minus 2 pi, and then plus 1 over 4 pi squared plus 1, like that. That was fun. 17, not as bad as I thought actually when I looked at it. 17, just take the derivative. These are not as interesting, but good skills to have. So the derivative here would be 2 sine x minus 3, subtract 1, times the derivative on the inside. The derivative of sine is cosine, so it's 2 cosine x. The derivative of negative 3 is 0, and that's it. Number 18, the second derivative. But in order to find the second derivative, we need to find the first derivative first. So I'm going to do that. So the first derivative is 3 over 2, subtract 1, and then 2t. Because I'm doing it again, a derivative again, I'm going to simplify it. So 3 over 2 times 2, they cross out, and I'm left with 3t, t squared subtract 1 to the 1/2. Now, I can do the second derivative, which is what it's asking for. And I have to use the product rule. The first times the derivative of the second, and subtract 1, it'd be negative 1/2, plus the second times the derivative of the first. So the product rule, and there's a chain in there too. Number 19. In number 19, find the points at which the line tangent to the graph f at x equals 2x subtract 3 cubed parallel to y equals 24x take away 7. So parallel means the same slope. So the slope is 24. I'm going to take the derivative here, and it has a hook. So I'm going to take the derivative and the hook. I'm going to make it equal to that slope and see what the x value is in that case. So 3 times 2 is 6. So when you divide, so 24 divided by 6 is 4. When you square root, the answer is positive or negative 2. So in one situation, it's positive 2. So So one answer is 5 over 2. So I'm going to add 3. In the other situation, it's negative 2. So when you add 3 to negative 2, it would be positive 1. So one answer is 5 over 2, and the other answer is 1/2. And then it asks for the point that goes with it. So those are the x coordinates that we're looking for. The point, you'd have to substitute back in. So if I plug in 5 over 2 here, the 2's cross out, 2 take away the 2's cross out, 5 take away 3 is 2, and 2 cubed is 8. So 5 over 2 would give you the answer 8. 1/2, if you plug it in, the 2's cross out, you get negative 2 when you subtract. Negative 2 cubed is negative 8. So those are the two numbers right there. 5 over 2, 8, and 1/2, and negative 8. Number 20. G at x equals f at x, that. And it says find the derivative at 1. So first of all, what's the derivative here? So 3 times 1 in front, subtract 1 to the exponent, and then the hook, the derivative of what's inside is this. Then plug in 1 to find the derivative at 1. So wherever there's a x, put in 1, and then we have values to put in. So f at 1 is equal to 2. F prime at 1 is 4, and then you're good. So 3 times 4 times 4, what is that? 48. All right, 21. So let's start here. So the derivative of this is the derivative of the outside times the derivative of the inside. If I want to find the derivative at 2, then I need to plug 2 in. And then I need the question, so it tells you what these values are in the question. So f at 2 is 3. F prime at 2 is negative 1. And then one more time, g prime at 3 is 5. And so that answer is negative 5. Number 22. Not 22, we're still in 21. That was A. B. The derivative of g at x and f at x. So this is the product rule, generically. So it's the first times the derivative of the second plus the second times the derivative of the first. And then to find the derivative at 2, we're going to plug 2 in for each one. And then in the question, we're going to plug in values that they're equal to. So in the question, g at 2 is 2. F prime at 2 is negative 1. F at 2 is 3. And g prime at 2 is 4. So that's 12 take away 2, so the answer is 10. C. So this is practicing, this is really important. These are totally AP style questions to practice the rules generically. So in this case, we're going to write it as g at x to the 1/2. And then when I take the derivative, it'll be 1/2 g at x to the negative 1/2. And then the hook, which is the derivative of what's inside. And then it says at 2. So I'm going to plug in 2 and get the values for that. So g at 2 is 2. G prime at 2 is 4. That's fine. If you wanted to, you can go 1/2 times 4, and then this means the square root of 2 in the denominator. Alright, D. This is the, which rule is this? G at x divided by f at x. Yep. So this is the quotient rule. The bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and then the bottom squared. And then again, I'm going to plug in 2. So I'll just get right to it. So f at 2 is 3. G prime at 2 is 4. G at 2, so I'm just looking at the question and plugging in the values. F prime at 2. And then f at 2 is 3, and we square it. So if I simplify it, it's 12 plus 2 divided by 9. 22. Turn the page. This is the end of the assignment, this page. Again, my goal is to keep the assignment under an hour, hopefully more like 45 minutes, even less. So I try my best to do that. Sometimes it might seem like I'm going fast, but you have a pause button. Find an equation of the line tangent to y equals 3 to the x when x equals 1.2. We're going to use our calculator. We need to know the x, the y, and the slope. So these are the things I'm looking for. To find the y value, it's 3 to the exponent 1.2. So I'll just do that with my calculator. Super easy. 3 to the exponent 1.2. And to 3 decimal places, so I'm just going to use 3.737. A little shine on that, but 3. Can you see it? There it is. 3.737. And then to find the derivative, we're going to find the derivative at 1.2. So, to find the derivative of that at 1.2, let's see, how would I do that? So with my calculator, I go menu and calculus and derivative at a point. And our x is our variable, 1.2. It's the first derivative, and then I type in 3 to the x, and then control enter, and the derivative is 4.105. Don't worry about rounding. And so we have y equals the slope 4.105, x minus 1.2 plus 3.737. Done. 23. We have a lot of questions in 23, so I'm not going to write all of that down, but I'm going to answer the questions to the best of my ability here and explain it to you. So a sprinter in a 100-meter dash is clocked at every 10 meters. So you can see how fast it is for him to cover until he gets to the end. So at the very end, 10.2, it's about as fast as I run it. 100 meters, that's really fast. How long does it take the sprinter to finish the race? Well, there it is, right? 10.2 seconds. B, what is the sprinter's average speed? That's A-rock over the first 50 meters. So the bottom row, top row is actually the Y value, right? I'm just double checking, right? Yeah. So the top is the Y and the bottom is the X. So the seconds is the input and then the output is the Y on top. So Y2 minus Y1, that's 50, take away 0, and 5.4, take away 0. Just Y2 minus Y1. And if you like, that answer is 10.416. And that would be meters per. So on average, that's how fast he's running, or she's running, in the first 50 meters. What's the sprinter's average speed over the second 50 meters? That's 100 take away 50. 10.2 take away 5.4. So still Y2 minus Y1 and so on. This time the average speed is exactly 10 meters per second. So in fact, he's slowing down over the last, or she is. That makes sense, right? The first 50 meters might be faster and might slow down if you're sprinting, just a little bit. What's the sprinter's average speed between 20 and 30? Well, that would be 30 take away 20, and 3.5 take away 2.5. So the average there, again, is 10 meters per second. E, what's the sprinter's average speed between 30 and 40? So again, 40 take away 30, 4.5 take away 3.5. Same thing, right? 10? Yep. Meters per second. F, what's the sprinter's approximate speed as he passes the 30-minute mark? So right here, what's the approximate? And we're talking, how do you approximate instantaneous? And so you have to take what's before and what's after and use that to approximate it. So it's going to be 40 take away 20, and it's going to be 4.5 take away 2.5. So you still have to do slope with 2 points. To approximate, you take the one after and the one before, and then find the slope in between. So that again is about 10 meters per second if you calculate it. During which 10-meter segment is the sprinter running the fastest? So where is the slope the greatest? And so the top is all the same, right? So in the bottom, you're looking for the least amount of time, right? So 1.4 take away 0, 2.5 take away 1.4. Where is the least? And it's actually right here. So 9.3 take away 8.5. That only took 0.8 seconds. And so it was the least amount of time to cover 10 meters. So you're going the fastest, right? So between 80 and 90 meters. H, during which portion of the race is the sprinter accelerating the fastest? So that's the change in speed. So if you look to see, he was or she is slowest at the beginning because it took 1.4 seconds. And then if you look at the next one and the next one, it keeps speeding up. So the acceleration at the very beginning from 0 to 1.4, that's when you accelerate the fastest. Because you're starting from 0, right? So the acceleration at the very beginning, there's no other segment where you're speeding up that fast from 0. All right, 24. A particle is moving vertically on the y-axis. We have this equation. And the question is, when is the particle moving up? So I need to take the derivative. I need to make it equal to 0, and then I'm going to factor it. And I want to know when the particle's at rest. So taking the derivative, which is really the velocity, at -3 and +1, it's at rest. If I plug in a number smaller than -3, so -4 and -4, it's a negative times a negative. And then I want to understand multiplicity to make this easier. In odd multiplicity, the signs are going to change. So the signs are going to change. It makes it a lot faster to understand. So when are they moving upward? So from -infinity to -3 and 1 to infinity. So we're looking for positive acceleration, and that's the answer. Number 25, the functions of f, the derivative, and the second derivative are shown. Determine which is which. So when you look at a function, it has to have the greatest degree. Like the biggest exponent is here, and then it gets less, and then it gets less. So do you see the cube function has an exponent of 3? Then the quadratic has an exponent of 2? And then the line has an exponent of 1. So that's it going down. So the function is the cubic, the derivative is the quadratic, and then the second derivative must be the linear, because as you're taking derivatives, it's getting 1 less, 1 less, 1 less. For 26, same idea. The function is the one with the greatest degree. So in this one, it's going to be the quadratic, and then the derivative is going to be a slanted line, if you like. And then the derivative of a slanted line is a horizontal line. So understand the one with the greatest degree and then work your way down to each derivative after it. 27, use limits for definition and use the alternate definition to do it. So the alternate definition is when x approaches 1, and that's x minus 1, we put in the function 5x squared minus 3x plus 2, subtract, plug 1 in, and you get what? 7 take away 3, that's 4, and then that's what we're finding the limit value of. So this simplifies to 5x squared minus 3x minus 2. I'm very confident that the factor x minus 1 is also in the numerator. So I'm going to use the fact that I'm pretty sure they're going to cross out. So that means this must be 5x squared. So they multiply together. Oopsie, sorry, that must be 5x, I mean. And this must be positive 2, because negative 1 times 2 is negative 2. So that's negative 5 plus 2, so it does match. So I used that fact because I knew that they were going to cross out. Plug 1 in, and you get the answer 7. 28, we're almost there. Barely at half an hour. No biggie, right? So number 28, the position function, s at t, 2/3 t cubed minus 5 over 2 t squared plus 3. It says find the displacement between 0 and 3. So that's what this is ultimately. So you plug in 3 and plug in 0. I would use a calculator. If you did that, the answer is just negative 4.5. So you're plugging 3 in, plugging 0 in, and then do the math. You can use a calculator to see. The second part is the total distance from 0 to 3. Well, to do that, I need to know the velocity and know when the particle is resting. So I'm going to find the velocity. That's 2t squared minus 5t. Make it equal to 0. I can factor out a 2. Sorry, factor out a t, I mean. And so one answer is 0. The other one is positive 5 divided by 2. And maybe a better way is 2.5. So if I think of 0 to 3, at 2.5, the particle changes direction. So if I plug in positive 1, the answer is negative. It has an odd multiplicity, so it's going to change signs. And so to do this, we're going to plug in 2.5 and 0 and get an answer. We're going to plug in 3 and 2.5 and get an answer. And then we make sure the answers are all positive. So this will give you an answer of 5.208. This will give you the answer of 0.0708. So again, we want to make sure that whatever answer you get, so the beginning, this one here, because it's negative, it's going to have a negative answer here. We want to make sure we write it as a positive answer and then add this up. And the total distance is 5.916. All right, last one, 29. What we don't practice, we're going to forget. That's why we're practicing everything. The height in feet of a ball thrown straight down from a tall building is given. That's negative 16t squared minus 22t plus 220. So A says, what's the initial height of the ball? So plug 0 in, and the height is 220 feet. What's the ball's initial velocity? So to find the velocity, negative 32t minus 22, the derivative. Plug in 0, and it's negative 22 feet per second. Makes sense, because it's thrown straight down. C, what's the speed of the ball? In the speed of the ball 3 seconds after it's thrown. So plug in 3, and it's the absolute value. So that's what? Negative 96, negative 22. So that's 118. So it's positive 118 feet per second. So speed is always a positive value. It doesn't matter what direction it's going. That's how fast the ball is going, even though it's going down. And D, the last one. How far does the ball travel in the first 3 seconds? So for that one, because it's being thrown straight down, it doesn't change direction. So that's displacement. So I plug 3 in, I plug 0 in, and it's 210 feet, which is good because the height at the beginning is 220, so it only has 10 more feet to go. So it's going to hit the ground right after 3 seconds. You're done. Mr. G Math over and out. I'm proud of you for doing your work. Until next time.